Welcome back. We're talking about notes adding and subtracting radicals. You can only add and subtract like radicals. Whenever it comes to adding and subtracting, I don't care what you're adding and subtracting, whether you're adding and subtracting plain old numbers, and really what happens is we start talking about like terms. Can you add together 2x plus 5x squared? No, because this 2 and this 5, even though 2 plus 5 makes 7, they're different types of 2's and 5's, right? This is like 2 apples and 5 oranges. You can't just combine them together and say you got 7 or something, okay? So these right here are not like, which means you can't add them up, okay? But if you do have like radicals, you can add them up. So let's say that instead of this, let's say we had 3x plus 8x. Could we add those two things together? Yes. And what is 3x plus 8x? It would be 11x. That's it. So when it comes to adding and subtracting, here's the number one thing you're going to mess up. You ready? You add the numbers in front, but you don't change the x at all. It stays as an x, and an x stays as an x. So when we get to number 1, we're going to follow all of those rules. Simplify this, add them together. Are we even allowed to add them together? Yes, because we have 7 and 7, so it is a match. And when we have 7 and 7, that means we can combine the numbers in front. What is 3 plus 9? 12. And what are we going to put inside the square root? 7. Remember, just like with the letters, when you add them together, 3x plus 8x, don't touch the x's. Don't change the x's. Don't modify them. So when we do radicals, it's the same rules. Add the outsides, but don't touch the insides. That's why we're going to run into some problems. We're going to run into some difficulties. People are going to accidentally put a 14 in here, and it's going to be wrong. Okay? Now, if you can remember not to touch the inside numbers, it's going to be easy because you just don't touch the inside numbers. All you got to do is add 2 numbers, and that's it. Okay? For a question like number 2, we have subtraction now. Do we have the same exact inside numbers? 3 and 3? Yes. So just imagine this question is x minus 4x. What would x minus 4x be? Well, it's kind of like 1x minus 4x. And what's 1 minus 4? Negative 3. And how many x's go on that negative 3? You just stay with 1, right? Don't change the x. So this question is exactly the same, except for instead of x's, we have square roots. Ayana, make sure you pay attention to the notes, please. So it's like 1 square root 3 minus 4 square root 3. And what's 1 minus 4? Negative 3. And what are we going to put in the square root? Still a 3. Don't change the inside number at all. So just subtract them, just add them, don't change the inside. So we get to number 3, and this is, a very classic question when it comes to adding and subtracting radicals. I see that we have square root 5. Then this middle one is square root 3. Now I'm going to use a different color because square root 5 and square root 3 are not the same. They cannot be combined together. The last one is square root 5. So we do have a little bit of a match. Okay? We can combine the 2 orange pieces of square root 5, but we cannot combine the green piece of square root 3. So all we need to do is 2 minus 14. Anybody know what 2 minus 14 is? Nice job. It is negative 12. And what square root is going to be on that 12? just a 5, right? Leave it the same, okay? That's this one and this one, and don't change the square roots. Now, what are we going to do with this piece here? This square root 3 has nothing to combine with, and just like we've done all year, you just bring it down, right? If you can't do anything, just bring it down to the next line, and that's your answer, okay? These two things can't combine. So, at the end of the day, here's what you want to read. Add or subtract the outside numbers, keep the inside numbers. Now, what if you have letters? It almost makes it easier if you have letters. Because if you have letters, you know you're not going to be adding those letters together, because that doesn't really make any sense. So when it comes to these letters, all you want to do is kind of identify your matching groups, like that X and that X. And then we also have this group of Y and Y. And remember, we're not going to be touching the insides at all. So when we get to the end of this question, we should be having a square root X part of our answer, and we should be having a square root Y part of our answer. We just need to figure out how many X's are we supposed to have. So when we add the orange pieces together, which is -9 and +7, if you want to use Desmos, just type -9 plus 7, and you get -2. So how many X's do we have? -2. And if we want to do the green pieces or the Y pieces, it's just +6 and -1. So you just go on Desmos and you type +6, -1, and it says 5. So you just have 5 Y's. Now, that's the end of the first top section. I do want to point something out to you. Students who don't do a very good job paying attention, playing the games, watching YouTube, okay, they're going to struggle with this green Y portion right here, okay? I see it every single year. I'm sure I'll see it today, which is kind of a bummer because I'm trying to point it out to you. 6 square root Y minus square root Y, okay? A lot of times, people will say that 6 square root Y minus square root Y, and they'll just be like, oh, if it's 6 square root Y, take away the square root Y, then they'll just say the answer is 6. Right? And of course, this is wrong. Okay? They'll just convince themselves, oh, you know what? I don't know what I'm doing, but if I'm supposed to get rid of the square root Y, then just get rid of it. That's not how it works. Okay? It needs to be 5 square root Y. Okay? This is correct. Because 6 minus 1, there's still 5 of them left. So if you start that question with square root x's and you start that question with square root y's, you're probably going to finish the answer with square root x's and square root y's. Now, let's get to the bottom here, because here's where it really gets tough. So far, honestly, that's pretty easy. Just add up the numbers. We haven't done any simplifying. We haven't really struggled at all. What if the radicals are unlike? Okay? Here is where we're going to really focus today. You know, if I could highlight this whole bottom half, I would just highlight this whole bottom half. Okay? This is where you want to spend all of your focus. If you feel like so far it's been very easy, here you go. Here's the difficulty. Okay? Number 5. We have an 8 and we have a 2. The 8 and the 2, are those like terms? No, these are not like terms. Can we add them together? No. Okay? With these two questions, with these two terms, you can't combine them. I'm going to hit you with a dot, 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 and then a yet. You can't combine them yet. And this is where the difficulty of adding and subtracting comes in. Now, 8 and 2, they do not match. You cannot combine them. But is 8 a prime number? Up here, we dealt with 7 and 3 and 5 and 3 and 5. And all of those prime numbers were prime. They were broken down all the way. There's no way we could have simplified them. So, when we look at question number 5, and we have this green 8, could we break down this green 8? Yes. Okay? So here's our goal. We're going to break down numbers until they match. That's our goal. That's what we're up to. Right now, they do not match, but we're going to break them down until they match. Okay? 99% of the time, once you break them down, they're going to be partners. Is Mr. Collier A1? Can I send him in like 5 minutes? Okay, perfect. Yeah, no problem. Bye. Jordan, once we get through like these notes, remind me. I got something to do for you. All right, number 5, which has an 8, which is 2 times 4, which is 2 times 2. Sorry for the interruption. We're going to circle our pairs. We're going to bring it outside. We have a leftover 2. This one's going to stay on the inside. And when we do all this and we simplify the 8, 2 comes outside. Don't forget there's already a 3 on the outside. So we should have 6 square root 2. Now this, which was already prime, we're just going to bring down 5 square root 2. And now our goal to break down numbers until they match. Look at what we got. Square root 2, square root 2. These are going to combine together finally. Final answer is going to be 11 square root 2. The 11 is simple. It's just 6 plus 5. 6 plus 5 is 11, and the square root 2 is going to stay as the square root 2. Okay, we're going to do a couple more questions, and this is 2 different people. We need to have Ayana and Maya. Go ahead. What's that, Ayana and Maya? Okay, I'll make you one in a second. Ayana, we have a little bit of problems, so make sure we're back on time, please. Girls, it should be 10:07. Okay. Let's just get into number 6, and let's just see how this happens, and you'll recognize it's not that first one. Maybe made it seem a little crazy. Here's what we got. 6 says 12 and 3. Do these 2 match? Can we combine them together? No. But if we do a really simple simplify, all of a sudden they're going to match, and we can finish the question. So 12 is 2 times 6, and 6 is 2 times 3. And we're going to circle up the 2's and be left over with a 3. And that's going to work out nicely because this question has a 3 on the inside, and we are about to have a 3 on the inside. Don't forget that we have a 2 and a 2 on the outside, which is 4 square root 3. And then bring down the one that can't be simplified, of course, it's just a 3. That's going to be negative 4 square root 3. Now we're getting to the end. We now have matching pairs. Now we can combine them. And what is 4 minus 4? It is 0. Okay? When we have 0, do we need to write 0 square root 3, or can we just stick with 0? So we can just stick with plain old 0. Okay? Remember, that square root 3, you can almost think of it like an x, right? When you do math, you don't write 0x. you just put 0, okay? And so our answer here is just a 0. If you go on Desmos and you try this out, what is 4 square root 3 minus 4 square root 3? It's just a plain old 0, okay? It's just an absolute nothing. So this, again, this is the same thing as 4x minus 4x. It's just, there's just nothing left. That 3 wouldn't change anyways, you know? It's like, this is almost like 4 apples minus 4 apples. What do you got left? Nothing. You don't need to say like no apples. You can just say nothing. That might, for this very first second, feel a little bit funky, but it's not too bad. And here's where we get to the real kind of expert level questions. 12, 27, 300. None of these are nice, simple. None of these are matches. None of these are prime. We're going to have to break down the 12, break down the 27, and break down the 300. Okay? Now these are relatively hard. In my mind, these are probably the hardest on the test, and I'll let you know that. So you're not going to have to do like 100 of these questions. You know, you only have to do a couple. The real thing here is organization is important, okay? If you've got to simplify 3 of these, some of your handwriting is so bad you can hardly simplify 1 of them. So make sure you're writing slowly. 12 is 2 times 6, which is 2 times 3. 27 is 3 times 9, which is 3 times 3. And 300, this one's going to take a little bit longer. 2 times 150, 2 times 75, 3 times 25, and 5 times 5. Again, I broke those down quickly. I just want to kind of get through these notes so we can get to the classwork today. When we break these down, we're looking to circle pairs, we're looking to find matches, and hopefully, when we're done with this process, we end up with matches. So, I've got 2 and 2, that's coming outside, left over 3. So I hope we have other ones that are left over 3. Circle 3, 3, that's coming outside, left over 3. Nice. These are going to end up matching because we have leftover 3s. When it comes to 300, 2 and 2 coming outside, 5 and 5 coming outside, leftover 3. Nice. All 3 of these are going to match because they all have leftover 3. And so final collection here, we should have 2 on the outside and an 8, which is going to make 16 square root 3. Don't forget about these numbers that are hiding in front of the square root. Up next, we have 3 times negative 7. Don't forget about that. It's going to be negative 21 with a 3 on the inside because there's a leftover 3. And this last one of 300 doesn't have any numbers out front at first, but a 2 and a 5 comes outside. That would make 10 square root 3. Okay, we simplified all of these down. We got down to square root 3, square root 3, square root 3. So all of these are going to combine together. We just need to add up the numbers in front and don't change the 3. Okay, don't mess with the 3. Don't make it a 6. Don't make it a 9. Leave the 3 alone. So we're going to have 16, negative 21, positive 10. That's the numbers in front of the square root. That makes 5. So we're going to have 5. And what do we do with the 3's? Don't touch them. Just leave the 3's alone. All right, one more question. I'm going to go considerably faster. We're going to get through this. Okay? I see 18, 27, 3, and 8. I'm going to try to break through these, break them down. I see 18. That's 2 times 9, which is 3 times 3. Nice. That one's finished. Up next is 27. 3 times 9, 3 times 3. Nice. That one's finished. Up next is this third term. This one is just a square root 3. I cannot break down a 3. 3 is already prime. So I'm just going to bring this one down. 3 square root 3 is not going to change at all. Okay? This is already simple. And the last one is 8, which is going to be 2 times 4, 2 times 2. Now I want to collect all 4 of these down here. I hope that I have some matches. 3 and 3 left over 2. 3 and 3 left over 3. 2 and 2 left over 2. Don't forget about the numbers out front. My first number here should be 3 square root 2. 3 on the outside, 2 on the inside. My second term should be 3 on the outside, and don't forget about my negative 2. So I'm working with negative 6 square root 3. I'll put a plus in here to space out my third term. That was already simple. And I'll finish up my fourth term, 2 on the outside. Don't forget my negative 6, which is going to make it negative 12 square root 2. Once I've simplified all these and brought all these down, I'm going to see a 2 and a 2. Those are going to work together. And I'm going to see a 3 and a 3. Those are going to work together. I'm going to combine these, but the 2's can only match with the 2's, and the 3's can only match with the 3's. So, what is for the oranges? 3 minus 12. Negative 9. And what do I do with the 2's? Nothing. Don't mess with the 2's. Now let's do my greens. It's a negative 6 plus 3. And what is negative 6 plus 3? It is negative 3. So my greens is going to be negative 3. Don't touch the square roots. Alright, so we're finishing up our notes here on adding and subtracting. At the top, don't forget, some of these questions are super easy. You just add them up. You don't have to simplify anything. The bottom, we did a lot of practice with questions that can't combine yet. You got to break them down and then combine them. Okay? I'll tell you right now, I hope you're paying attention. This video is going to be on YouTube. If you didn't pay attention to these notes, if you were telling yourself, I'm kind of paying attention while I watch baseball highlights, this is going to be a really tough lesson, okay? So make sure if you weren't paying attention, you take it serious.